Welcome back to my channel. In today's class, we are going to learn about parallel plate capacitor. What is a parallel plate capacitor? The physical concepts related to the parallel plate capacitors and various physical equations that's related to parallel plate capacitors. And then we are going to derive the expression for capacitance of a parallel plate capacitor. Let's come back. What is meant by the parallel plate capacitor? Let's take two metal plates. And having a cross-sectional area of A, and let these two metal plates are separated by some distance, separated by a distance d. Let d be the distance between the parallel plates. Both the plates have the same area. Both the plates have the same area of cross section. Now take these metal plates and connect it to the negative and positive terminal of a battery. So this battery charged the parallel plate capacitor. What is the meaning of it? So the plate which is connected to positive terminal of a battery is positively charged, and the plate which is connected to a negatively charged terminal of a battery is negatively charged. And it is found that after some time, when it is completely charged, it develops a plus Q charge on the positive plate, minus Q charge on the negative plate. When it is completely charged, then you can cut off this. Once if you charge the capacitor, you can just remove this cell, and the capacitor is found to be still charged. Yes. So now you have the two plates. Plate A means the first plate is positively charged, the another plate is negatively charged. Or plate 1 is positively charged, plate 2 is negatively charged. You know that there exists an electric field moving from positive plate to the negative plate. So this is the direction of the electric field exists between the plates. The direction of electric field is from positive plate to the negative plate. If V is the potential difference, between the plate 1 and plate 2, it is found that the electric field is related to the potential difference between the plate divided by the distance between them. E is equal to V by D, or V is equal to E into D. Potential difference between the two plates in case of parallel plate capacitor. Yes. Now let's assume that let Q be the charge on the plate 1, and if A is the area of cross section of the plate, you can define a physical quantity called a surface charge density, represented by the letter sigma. Surface charge density, it is nothing but charge by a total area of the first plate. Similarly, for second plate, you can write that because second plate also has the same area A, surface charge density as a minus Q divided by A. And D is the distance between the two plates. and it is found that the distance is very small when compared to the area of a cross section. Hence, as a result, the electric field is found to be parallel and equally spaced. So that suggests that electric field is E is parallel and it is same everywhere between the plates. Yes. Now our next challenge is to derive an expression for the capacitance of the parallel plate capacitor. What is the meaning of the capacitance of the parallel plate capacitor? Suppose if you charge the capacitor by connecting it to a cell of potential difference V, then charge developed is found to be proportional to the EMF of the cell or the potential difference between the cell. More the potential difference between the two plates, more the charge. More will be the potential difference between the cells when you connect it to a cell with higher potential difference. Therefore, the charge developed on the two plates is directly proportional to the potential difference between the two plates. If you want to equate it, you have to multiply by a constant. The constant of proportionality C here used is called as capacitance of the capacitor. Capacitance of the capacitor is a constant. Capacitance of the capacitor. Yes. So here we have to derive an expression for capacitance of the parallel plate capacitor. We have taken a parallel plate capacitor here. Before deriving the expression for the capacitance of a parallel plate capacitor, you should know an information which you have already learned in the electrostatics first lesson. That is derivation of the electric field at a point due to infinitely large charged plane. Let's take a plate and it is charged and its dimensions are infinitely long. And in previous class you have derived an expression for electric field at a point from some distance from the charged plate E. This is by using Gauss theorem. You have derived that. So the electric field at a point is given by sigma by 2 times the epsilon naught or half of sigma by epsilon naught, where sigma is the charge density of the plate. So it is a Q by A. And epsilon naught is the permittivity of free space. Assume that the point P is in air or vacuum at a point P. So you have derived that electric field is given by half of sigma by epsilon naught. And one more thing very carefully you should understand here is that the electric intensity equation do not depend upon the distance. Wherever the distance, whatever the distance of the point P, whether it is closer or farther, it is found that electric intensity is the same. And take at any place, take the point P anywhere. So the electric field at all the points are same because the direction of electric field lines comes parallel from the plate, and these electric field lines are perpendicular to the plate. That we have learned in the earlier or in one of my videos also you can find the derivation of the electric field at a point due to a infinitely large Okay, so charged plate. Okay, charged plate. Yes. What you have to remember? So you have to remember this equation. Electric field at a point due to a, okay, electric field at any point due to a parallel, due to a charged plate is given by half of sigma by epsilon naught. Now let's come back. Yes, come back to this place. So here, let me remove even this cell also to which it is connected. Okay. Now take the parallel plate and identify the three areas. One is the area, means one is the space above the positively charged plate. Another one is the space below the positively charged plate. And another place is the space in between the parallel plates. In between the parallel plates. Now let's remove even this also. Okay. Yes. Now let's take a point. Let's take a point P, which is just above the positively charged plate. What is the electric intensity at the point P due to the positive plate? It is away from the positive plate. It is given by half of sigma by epsilon naught. We are taking only magnitude. Similarly, what is the electric field at a point due to the negatively charged plate? Assume that there is no positively charged plate, or even if it is positively charged plate is present, the electric field at the point P due to the negative plate will be equal and opposite direction. It is in this direction. So here both of them magnitude are same because the two plates are equally charged. One is by plus q, another one is minus q. This plus and minus, okay, gives only the direction, and magnitude they are same. So therefore the net field, so net electric field, okay, is 0 here in the, okay, space represented by 1. Now similarly, okay, so find the space similarly, let's take a point Q below the plate. Let's take a point Q below the plate. Here also, electric field intensity due to positively charged plate is away from the plate. So E due to plus charge, positively charged plate is again the quantity same, half of sigma by epsilon naught. Okay, sigma by epsilon naught. And what is the electric field? Okay, what is the electric field due to negatively charged plate? It is towards the negatively charged plate. It is minus, okay, it's due to minus charge. It's again same thing, half into sigma by epsilon naught. As here, okay, here also same. Here also same thing. So both they are get equal and opposite and they get cancelled. So they get cancelled. Okay, E net is 0. It's get cancelled. Next, what about the electric field between the plates? Electric field between the plates. Electric field between the plates. Suppose take a point R. Here the direction of electric field is away from the positively charged plate. So there is E plus Q, and again the electric field due to negatively charged plate is again towards the negative plate. So that is E due to minus Q. So what is the net field? It get added up. So hence the net electric field between the plates. So net electric field between the plates is equal to E due to plus charge and E due to minus charged plate. So that will be equal to magnitude. So plus charged. You have to add them. So this is half of sigma by epsilon naught plus half of sigma by epsilon naught. So that becomes half plus half is 1. So therefore, electric field between the plates. Electric field between the plates. Electric field between the plates is given by just a sigma by epsilon naught. Sigma by epsilon naught. Yeah, so this is the important stage in the derivation of the expression for capacitance of a parallel plate capacitor. Yes, this is just the explanation. For derivation, let's use the different simplified diagrams and all the informations that we have learned so far. Now let's come back, and already we have studied that if V is the potential difference between the two plates and D is the distance between the two plates, electric intensity is obtained by the ratio of potential difference by the distance between them. This derivation also we have learned. So earlier this we have learned in the form of minus dV by dx, where if there is a small distance between the two plates with a potential difference of V volt, that is the ratio. Minus charge indicates only the direction of the dx and E. Now we are taking only the magnitude of these things. Therefore, E is equal to V by D. V is equal to E into D. Now make use of this. Make use of this equation here. Make use of this equation here. Yes. What is the capacitance of a parallel plate capacitor? So the capacitance of the parallel plate capacitor C is given by so Q by 1 minute. So it is found that the charge developed is proportional to the potential difference. If you want to equate it, you have to multiply by a capacitance. So Q is equal to C into V. Therefore, Q is equal to C into V. Instead of V, let me write E into D. This derivation can be done in different ways. No problem. So you can just follow one particular method. Now Q is equal to C into E into D. Instead of E, you can just write down this derivation of what we have done. So electric intensity between the plates is given by E is equal to so yes, sigma by epsilon naught into sigma by epsilon naught into D. Now into D. Right. Yes. And next, so Q is the charge on one of the plate. So capacitance is C. What is the sigma stands for? Sigma is nothing but surface charge density. Surface charge density of the plate, which is nothing but the charge developed divided by area of cross section. Therefore, you can just write instead of sigma Q by A and into epsilon naught into D. Now you can cancel this Q and Q. Here it becomes 1. Cross multiply. So A into epsilon naught by D is equal to capacitance. Therefore, capacitance of the parallel plate capacitor can be properly written as epsilon naught A divided by D. So where epsilon naught is the area of cross section, and d is the distance between the parallel plates. So therefore the capacitance of a parallel plate capacitor is directly proportional to the area of cross section of the plate. Larger the area of cross section of the plate, more the capacitance of the parallel plate capacitor. Smaller the distance between them, and higher the capacitance of the battery, of the capacitor, higher the capacitance of the parallel plate capacitor. Okay. Epsilon naught is the permittivity of the free space or air or vacuum. Suppose instead of air, if any other medium is present, its permittivity is simply written as epsilon A by D. Epsilon A by D. For a different medium, so for different medium other than vacuum, for different medium, it is found that permittivity of the medium is related to the permittivity of the free space by one constant. That constant is called as dielectric constant. So dielectric constant, it is called as a dielectric constant. Okay, students, how to answer the derivation for the expression of capacitance of parallel plate capacitor in the exam. So first you have to give some introduction and then write the relevant diagram, and then you can proceed with the equations. What is the assumptions you can write? Consider a parallel plate capacitor of area of cross section A, and D is the distance between the plates. Let air or vacuum is the medium between the plates. Then you should draw the diagram. So two metal plates, one is positively charged, another one is negatively charged. This capacitor is already charged. D is the distance between them. Then select the three spaces, space 1 outside the capacitors, above the capacitor, space 2 outside and below the capacitor, and space 3 between the capacitors. And then you have to write it. What is the direction and magnitude of the electric field due to positive capacitor? It is away from the positively charged plate, and so this is away from the positively charged plate. Okay, so that is the value that you are supposed to write it. Okay, and then so what is the electric field due to negatively charged plate? It is equal in magnitude but opposite in direction. And then you have to mention what is the net electric field outside the capacitor. So it is 0. They are equal and opposite electric field. Similarly, same thing you have to write it. Okay, below the capacitor, outside the outside the plates in the region 2, the direction of electric field is always towards the negatively charged plate. Hence you have to write this direction of E minus towards the positively charged plate, and E plus is away from the positively charged plate. Away from the positively charged plate, the net electric field is 0. And then inside the capacitors, the electric, select one point, say P, in the region, third region, the region between the plates. So electric field due to positive plate is away from the positive plate. Okay, hence E plus is written. At the same point, E minus is towards the negative plate. What is the total electric field? Total electric field get added up. E plus, E plus and electric field due to negative charge. So that get added up. So this is what you are supposed to write it. So this is E is equal to electric field due to positive plate and electric field due to negative plate. Then you know its value. Value, that is half of sigma by epsilon naught. Half plus half of sigma by epsilon naught. Half plus half, it becomes 1. So it is just sigma by epsilon naught is the total electric field between the plates. And they are parallel plate capacitors, and there is a uniform electric field everywhere. So therefore the electric field is represented by the equally spaced parallel lines. Whenever the electric field lines are written equally spaced parallel line, it is understood the electric field is uniform everywhere. In all the points electric field is same. Okay, yes. Then, okay, you can come back to the previous equations. When the capacitor is completely charged, so the charge is related to the potential difference between the plates as given by Q is equal to CV, and where C is the capacitance of the capacitor. And electric field is also related to the electric potential by the equation E is equal to V into D. Cross multiply E into D becomes V. Now substitute this V here. Q is equal to CV becomes C into E into D. And E you can replace it in C is C into epsilon by epsilon naught into D. Yes. Now, so you can replace that. The surface charge density is nothing but the charge divided by area of the plate. Okay. So sigma is replaced. Sigma is replaced by Q by A. Okay, Q by A. Now Q get cancelled and cross multiplied. And A into epsilon naught, okay, is equal to C into D. And finally, you can arrive at the expression C is equal to epsilon naught A by D. Okay, yes. For different dielectric medium between the parallel plates, E naught is replaced by E. The E is called as permittivity of the dielectric medium. Dielectric medium may be different insulators. And permittivity of the dielectric medium is related to the electric permittivity of the free space or vacuum. By using this equation, epsilon is equal to epsilon r into epsilon naught. Now replace it in the equation. Replace that in this equation. You will get C is equal to epsilon r epsilon naught A by a D. Okay. Yes. From this equation, it is also possible to calculate the dielectric constant C. Okay, in the medium. Find out the capacitance of the capacitance in the medium divided by the capacitance in the air. All the constant get cancels, only relative, only dielectric constant is remaining. Okay, yes. This is how to write the answer for the derivation. Okay, students. So I think we come to an end of the derivation. In the coming lessons, we are going to learn what happens to the capacitance when capacitors are connected in series, or what is the effective capacitance. What is the effective capacitance of a capacitor when the many capacitors are connected in parallel? Those derivations we are going to do in the next class. Okay. Yes, that's all for today. Okay. I request you, if you want to support me, please subscribe to my channel and then press the like button and get the notifications so that whenever I upload a new topics, it will reach you. Plus, share this information with all your friends and help them also. Thank you very much.